Regarding the SOMA project, it has manifold aims, so it's hard to tell it in short.
So the basic idea is to get notice about situations of interest in any of these application areas.
SOMA is a very ambitious project. It tries to find out how actually self-organizing multimedia systems really work.
The whole project is dealing with different aspects of self-organizing and self-organizing systems, including people who are organizing themselves in a more or less autonomous way, for example, to get better information in shorter time, but also technical equipments who are organizing themselves in order to get a higher throughput or a better quality of service for the delivery of videos. And also some self-organizing aspects between different layers and aspects of such a complex system.
The main goal is to, as I mentioned, this architecture, to develop this architecture to identify so-called situations of interest. Well, situations of interest you cannot define in a common way. So, situation of interest is always depending on the time, on the location, and on the interestingness of the persons in this happening.
There will be autonomous sensors like audio sensors, cameras, things like that, like surveillance cameras, like surveillance equipment, and they'll try to register situations of interest or events.
Although we not even can tell it exactly what is an event. So for just an example, we are now sitting in the room and now somebody is entering, this is obviously an event. But if you have many people doing a lot of interesting things, then maybe the event is that they stop doing it.
Basically, the architecture is divided into 3 layers. The bottom layer is the sensor layer, where we have our, let's say, automated sensors, which are sensors like acoustic sensors, some microphones connected to some computers, or smart cameras, which have the processing on board, which capture some pictures and then they analyze these pictures. So this is the sensor layer which gathers this sensor data and tries to derive new information out of this sensor data to provide it to the next layer.
In the middle, like communication layer, there is the distribution layer. It receives events from the users, it receives events from the sensors, and it distributes them through different proxy nodes.
The users themselves, they consume the data, and they can also provide their own data to the system, so they can become also sensors. So it is a layered architecture, but not in a really clean way, because the users, which are the third layer, also can become sensors in our system. We have 5 different use cases, and each use case is targeted at a different application domain, so that we have different situations of interest there. For example, we had this SOMA World Games, which is in the application area of entertainment, and there we had situations of interest like jumping or laughing or falling or rolling. So movements in particular, where there's a lot of motion in it. Together with our partner Asfinag, we have the traffic domain, and in the traffic domain we have, for example, congestion or slow traffic or accident, so different happenings. So what we try to do is to develop an architecture where we are able to identify these situations of interest with respect to the application domain on the one side, and to present this information to users, which are possibly a large set of users, large crowd of users, so that they gather this information and have the benefit at the end.
In the SOMA World Games, we've prepared 5 different rooms, which are actually 5 different places all over the world. And in 4 rooms we have 4 different games. Rock Band, which is a music game, SingStar, which is very popular. There's a skateboard game, and there's an action, sports action game from Nintendo Wii. And people are doing, playing the games, having fun, playing them collaboratively, things like that. And in this sequence of playing games, certain situations, funny situations happen, interesting situations happen. And what we do is we try to find and gather those situations in the world games. And there are two ways to gather them. There can be users who take the cameras and capture the movement, the action, and there are surveillance cameras which do this automatically. Surveillance cameras have to decide is this a situation of interest or not, upload it to the system, and the users can do this themselves, but still they have to turn on the camera and upload it manually, things like that. But that's the main idea. A lot of people went there, played with 4 different types of computer games, they had a lot of fun, and it generated a lot of videos and pictures and uploaded them, emailed them to our system. So a lot of people were doing things with the system. There were also cameras, surveillance cameras, registering situations, uploading them to our system, but it was mainly about the users because they had a lot of fun, they did their thing with their video cameras, with their photo cameras or their mobile phones. With the ASFINAG it is very different. There we have very few users who actually participate in the network. There are some few consumers, but there is a huge lot of cameras. So we can gather data from a lot of cameras all around the highways in Austria. Basically both multimedia information systems, but from very different perspectives.
So we bring reliable information from the systems, from the sensors to the users, telling that there are some congestions on the road or something like that. And this is what our project is about, detecting situations of interest, communicating these situations of interest to the users and getting feedback from the users at the end.